The Miller cycle engine and the Atkinson cycle engine are both variations on the traditional four-stroke spark ignition engine. These engines operate more efficiently but produce lower power outputs. In a conventional four-stroke cycle, the compression stroke and the power or expansion stroke are symmetrical. The compression and expansion ratios are calculated by adding the volume of each whole stroke to the volume of the combustion chamber and then dividing that figure by the combustion chamber volume. In a conventional four-stroke engine, the stroke in each cylinder is the same length, so the ratios are the same. Increasing engine efficiency by extending the stroke and raising the expansion ratio also raises the compression ratio. There's a limit to how high the compression ratio can be, because raising it too much results in premature detonation without ignition. The Miller cycle and the Atkinson cycle overcome this by using valve timing variations to make the effective compression and expansion strokes asymmetrical. The effective compression stroke is shortened by delaying the closing time of the intake valve at the beginning of the compression stroke. The combustion chamber is smaller than that of a conventional engine, so the compression pressure at ignition is still typically the same as that of a conventional four-stroke engine. The effective expansion stroke is lengthened by delaying the opening of the exhaust valve, so all the pressure created by the expansion of the combustion gases can act on the piston until they're completely dissipated, applying pressure to the crankshaft for a longer period and increasing efficiency. Both engines use a large throttle opening but induce a small amount of air. This results in lower manifold vacuum, reduced pumping losses, and increased efficiency. The Miller cycle engine adds an engine-driven compressor to the intake system to boost power output when required. When the engine is operating at low load and speed, the compressor is not needed. A clutch disengages the drive, so there's no unnecessary drag on the engine. When extra power is required, the clutch is engaged and the compressor boosts the amount of air drawn into the engine, supercharging the cylinder. The Atkinson cycle engine is efficient within a specific operating range, typically between 2,000 and 4,500 rpm, but its power output and torque are lower than a conventional engine. This type of engine is less useful as a primary power source, but is ideal in applications such as a series parallel hybrid vehicle, charging and working in tandem with a battery-driven electric motor. The lower maximum operating speed allows engine components to be of lighter construction and weight when compared to a conventional engine. Lighter and smaller components reduce friction and increase engine efficiency. In addition, the crankshaft is mounted slightly left of centre. This has the effect of lessening major thrust load on the piston, reducing friction.